For this example, let's assume we have a 350 cubic inch V8 engine and we want to calculate the amount of fuel we need to supply to achieve a target air-fuel ratio of 12.5 to 1. We'll also assume that the engine is operating at wide open throttle at 6,000 RPM for our calculations. The first step is to calculate the airflow through the engine at 6,000 RPM. The formula we need to use to do this is shown here, and this comes from the earlier module on volumetric efficiency. In the equation we have V, which is our engine capacity in cubic inches. We have our engine RPM, which we're dividing by 2, since we only have one intake stroke for every 2 engine revolutions. And we have the constant 1,728, which we're using to change the units from cubic inches to cubic feet. Let's drop the numbers from our example into this equation now, and if we solve the equation, we get an answer of 607 cubic feet per minute. So now we've calculated the volume of air passing through the engine at 6,000 RPM. As we already know though, it's not the volume of air we're interested in, and what we really need to know is the mass airflow through the engine, because this will allow us to work out the mass of fuel required in order to achieve a specific air-fuel ratio. To calculate the mass airflow through the engine, we need to take volume airflow and then account for air density. Remember that we covered air density and how to calculate it in the air density module earlier in the course. The formula for mass flow is shown here and is simply the volume airflow multiplied by the air density. For our example, let's assume that we're operating under standard conditions for temperature and pressure. Remember that we can calculate air density using the formula shown here. Let's substitute some values into this equation and solve it. Remember, under standard conditions, the air pressure is 14.7 pounds per square inch, and the air temperature is considered to be 519 degrees on the Rankine scale. The value 2.7 is known as the specific gas constant, and this is a constant value in the equation. Solving the equation gives us the value of 0.076 pounds per square inch. Now we have the volume airflow and the air density, we can drop these numbers into the mass flow equation. Solving this gives us a mass flow of 46.1 pounds per minute. If we also assume that the engine is fitted with one injector for each cylinder, we can then break our example down to just consider a single cylinder. To do this, we need to calculate mass flow per cylinder, which is pretty easy, as we just need to divide the total mass flow by the number of cylinders, in this case 8. Solving this equation for our example gives us a mass flow per cylinder of 5.77 pounds per minute per cylinder. Now that we've calculated the mass airflow, we can move on with the process and calculate the required fuel mass.